Let's explore auditing database activities. In this video, we will cover tracking and monitoring database operations to maintain security and compliance. Let us understand what and why database auditing is needed. Database auditing is a systematic process of tracking and recording database activities. It captures who did what, when, where, and how, and creates a chronological record of database operations. It also monitors both system and user-initiated actions. Now let's discuss why we audit databases. Auditing is crucial for security to detect unauthorized access and suspicious activities. It ensures compliance with regulatory requirements such as GDPR, HIPAA, and SOX. Auditing aids in forensics to investigate incidents and data breaches. Finally, it helps in performance monitoring to identify inefficient queries and operations. Let's explore the different types of database auditing. First, we have statement-level auditing, which tracks specific SQL statements, monitors statements like select, insert, update, and delete, and captures statement execution details. It provides low overhead for targeted monitoring. Next is privilege-level auditing. This monitors privilege usage and changes, tracks grant and revoke operations, records privilege escalation attempts, and is essential for security compliance. Another type is object-level auditing, which focuses on specific database objects, monitors tables, views, and procedures, tracks schema changes such as alter and drop, and is useful for critical data protection. Lastly, we have fine-grained auditing, which provides highly detailed and conditional auditing, monitors specific rows and columns, uses policy-based conditions, and while it has higher overhead, it offers maximum precision. Let's delve into how database auditing is implemented. We'll begin with Oracle Database. To enable standard auditing in Oracle, use the command alter system set audit _trail equals db scope equals sp file. This enables auditing at the database level and requires a database restart. To audit all select statements on the hr.employees table, use the command audit select on HR employees. To audit failed login attempts, use the command audit session whenever not successful. Oracle provides built-in auditing capabilities through the audit command and stores results in the sys.aud$ table. Now let's look at SQL Server auditing. To create a server audit, use the command create server audit data access audit to file and specify the file path. To create a database audit specification, use the command create database audit specification user table audit for server audit data access audit ADD, and then specify the events you want to audit, such as select, update, and delete, on the relevant database objects. SQL Server uses server audit objects and database audit specifications to configure comprehensive auditing. Continuing our discussion on database audit implementation, let's explore MySQL and PostgreSQL. For MySQL auditing, first, you need to enable the Audit Log plugin with the command install plugin audit_log sonomy, audit_log.so. Next, you can configure audit logging in the my.cnf file. For example, set audit_log_format equals JSON and audit_log_policy equals all. Finally, to create trigger-based audits, use the command create trigger users _audit_trg after update on users for each row insert into audit_log values, and then specify the details you want to capture. Please note that MySQL Enterprise Edition includes the Audit plugin, while Community Edition requires custom triggers or the MariaDB Audit plugin. Now let's look at PostgreSQL auditing. To enable the PG Audit extension, use the command create extension pgaudit. Then configure the settings in the PostgreSQL.onf file, such as pgaudit.log equals right, ddl, and pgaudit.log_catalog equals on. To create an audit rule for a specific table, use the command alter table customer enable always trigger audit_trigger. PostgreSQL offers the PG Audit extension for comprehensive auditing and can be enhanced with custom triggers for specific needs. Let's discuss Audit Log Management. Firstly, we have storage and retention. It is important to store audit logs in a secure, tamper-proof location. Implement log rotation to manage file sizes, define retention policies based on compliance requirements, and consider archiving older logs to cold storage. An example log rotation configuration is shown on the screen. Next, security and integrity is important. Encrypt audit logs at rest and in transit, implement digital signatures to detect tampering, restrict access to audit logs using the principle of least privilege, consider write-once media for critical audit data, and separate audit log management from database administration. When we talk about performance, remember that audit logging adds overhead to database operations. Be selective about what events to audit, consider asynchronous logging for better performance, monitor audit log size and growth rate, and schedule intensive auditing during off-peak hours. Finally, to perform analysis and reporting, use CM tools to centralize and analyze logs, create dashboards for audit log visualization, set up automated alerts for suspicious activities, generate compliance reports for regulatory requirements, and correlate database audit logs with other security logs. Let's explore the tools available for database auditing and summarize the key takeaways. Here are some commercial tools available: IBM Guardium, Oracle Audit Vault, McAfee Database Activity Monitoring, Imperva SecureSphere, and Quest Enterprise DB Audit. For open source tools, consider PG Audit for PostgreSQL, MariaDB Audit Plugin, Percona Audit Log Plugin, the ELK Stack for log analysis, and OSEC for security monitoring. Also consider CM integration, Splunk, IBM QRadar, Logarithm, ArcSight, and Graylog. Now let's recap the key takeaways. Database auditing is essential for security, compliance, and operational integrity. Different audit types serve different security and compliance needs. Implementation varies by database platform, but the core principles remain consistent. Balance comprehensive auditing with performance considerations. Secure audit logs are as important as the auditing process itself. Finally, effective auditing requires planning, implementation, monitoring, and continuous improvement. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.